There can be many situations of projectile motion involving inclined plane. Somebody throwing something from here at some angle, that thing hitting somewhere here. Somebody can go for horizontal projection and that thing hitting somewhere here. There can be many situations. Oftentimes, while dealing with these situations, we go for different XY system that we are accustomed to. We are, as you know, accustomed to this type of XY system, and that we may change in such a scenario. The plane of the projectile, along that there can be a line that can be considered as x-axis. Then perpendicular to that, that can be considered as y-axis. That's a very common technique. The little disadvantage of doing that is, if you take the typical XY system, then because G is acting downwards, then you have an advantage in the motion for X direction. For X direction, you can always say that there is no acceleration, so the component of velocity along X direction will never change. That's the advantage of this XY system. And if we go for that XY system that I'm talking about, imagine this is x-axis along the plane of the incline, and this is perpendicular to it, which is y-axis. Now if you look at G is always going to be downwards. But then your two motions, both of them are going to have non-zero acceleration. So one component of G here, another component of G here. So that's the little disadvantage you have, but there are of course advantages. For example, if the question is asking you the range for a motion of this sort, and range is now defined as this, then you can clearly see that it should be an advantage to take this as your perhaps x-axis. Question is asking you for range, say for example. Then later on, when we talk about collision and bouncing, then later on also you can see projectile motion based problems involving collision. So the ball or some point, some particle hits the incline again, and then bounces up. And for those problems, you want to apply the law of reflection. The same law of reflection which you discuss in optics, angle I equal to angle R. So suppose you want to apply something like that, then is it not convenient if you treat this as one of the axes? So that is a key point, one of the key points. Choice of your axis system in case of inclined plane. Method is the same. Two axes, two motions, write the equations and simplify. So any problem can be handled. So I will take some problem and I will illustrate this particular situation of inclined plane. Inclined plane is at theta angle with horizontal. Particle is projected horizontally. Horizontally means parallel to this. How far from the point of projection will the particle strike the plane? Basically range. Range is being asked, this distance. Okay, so we will take this as our x-axis. And that one as y-axis. Now, G. G is like that. If this angle is theta, can you tell me what will be AX? X component of acceleration? You know that angle, so that should not be a problem. That angle is 90 minus theta. This is 90 minus theta. This component will be g cos 90 minus theta. G cos of this angle, and that angle is 90 minus theta. If you have problem in understanding that, let me know. If it is all right, then I will talk about AY. Other component of G will be along this direction, and that will be G cos theta. But that is not AY. AY is in opposite direction, so it will be minus G cos theta. Okay? Now we can write the equations, two of them at least, one for x direction, one for y direction, at least. For x direction, now it is not constant velocity case. For x direction, it is not constant velocity case. Acceleration is there along x direction. So if we take any point xy in the path, then x equal to ux t plus half ax t square. Okay? How much is ux? What is the x component of u? Let me know when you work it out.
Sir, u cos theta?
U cos theta. That is correct. So this angle is theta, so it will be simply u cos theta. Now, y direction. T is same, whether you consider x motion or y motion, T is same. Ay is minus g cos theta. Okay? That is for any point in the path, any point. But we are interested in this point in particular, this point. What is special about that point regarding y motion? What is special about that point regarding y motion?
Sir, the velocity would be 0.
Why would it be 0? I don't think. Anything else? If motion is horizontal, in this drawing, if motion is parallel to inclined plane, then you should say that Vy is 0. If motion is parallel to inclined plane, then Vy will be 0. And that happens somewhere here. At this point, if you see, then the motion is parallel to inclined plane. That's where Vy will be 0, not here. Anything else? Look at displacement along y direction. Do you find any displacement along y direction? There is no displacement along y direction. Y direction is perpendicular direction to the inclined plane. Along that direction, where is the displacement? It was 0, y, and y is 0 even here. So, put y equal to 0 for this point. Find time. That time will be the time of flight, total time of flight. Put that time here, and you will get range. Put y0, find time, which is the time of flight. Time of flight cannot be 0. Put that capital T here, no, here and here. Simplify as much as you can. That will be the answer for range. I'm writing it down here on the board. See if your working is matching with that or not. Any questions? Let me know. As seen from the truck. Now think like this. Suppose this person gives the ball some horizontal push in this direction. A component is enough. Component. Gives the ball a push so that it has a horizontal component. The general rule is that if a body falls from the moving object, it carries with it the velocity of the thing that was moving, just if it is dropped. If a ball is not thrown but just dropped, say you drop a ball here, truck is going to the right side, you drop a ball. Ball will carry the same horizontal velocity that the truck was having. Then why does it fall if it had the same velocity that truck was having? Well, because of vertical component of velocity. Because of gravity, there was a zero vertical component. When the ball was here, the vertical component of the velocity was zero, because somebody was there to stop it from falling, this floor, or whatever you call it, where it is kept on the truck. So it would not fall. It will have zero vertical component of velocity. But when you drop it here, who is there to stop it from falling? So it does have the same horizontal component, 14.7, that is, same 14.7 when you drop it. But because there is a non-zero vertical component, that it falls and hits the ground. Moreover, for practical purpose, you can't neglect air also. For practical purpose, you can't neglect air also. Air has got resistance. We have been neglecting it in projectile motion in totality, air resistance. Otherwise, how can it be parabolic if there is air resistance? Right? Now, if there is a horizontal push forward, it has already 14.7 speed in horizontal direction. Already it has it. And you are giving some more by imparting a horizontal push. So horizontally speaking, the velocity will be more than 14.7. Maybe 16 meters per second. If there is a horizontal push component is enough. That makes 14.7, 15 or 16 or 17. Now think like this. Truck is going at 14.7 and the ball is going at 16. Same direction. How will you ever be able to catch the ball? Ball is traveling faster horizontally. So it will fall ahead of you. You can't catch it. To catch the ball, yours and ball's horizontal velocity should be identical. Horizontally you should not travel different distances. Only then you can catch it. So that is only possible if 14.7 does not become 15 or 16 or 17 for the ball. It remains 14.7 only. That means you should not give it a horizontal push at all. Zero horizontal push should be given. If at all you want to give it vertical push. So that person is able to catch the ball. That's only possible if in X direction they travel same distances in same time. And therefore, that person is giving it absolutely upward push, vertical push like that. Hand is not making some angle like that, but is absolutely straight up. With respect to him, as seen from the truck, I'm saying, as seen from the truck, it should be absolutely up. But it can't be going absolute up, because while the person gives it a vertical velocity, it can't, it has horizontal velocity of 14.7 with it. That's always there, 14.7. So 14.7 is there, and now vertical is also there. So the two velocity components give it a parabolic path like this. And horizontal at every point remains 14.7. Horizontal velocity, how can it change? We neglect air. Who else can change it? So the vertical push is basically giving the vertical component of velocity. This is that vertical component, Uy. This is 14.7, 14.7, 14.7, 14.7, 14.7. So angle of projection as seen from the truck, what would you call it? 90 degree. How about the speed now, Uy? The time taken by the truck to reach from here to here, in the same time, the ball should go up and come back. Vertical motion I am saying, only vertical motion. In fact, how will it look to that person? So that person, ball is not going in parabolic motion. That person will always see the ball is above him. So that parabolic motion is for somebody who is watching it from the ground. For the person who is on the truck, ball is not going in parabolic path. Ball is just going up, 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 down, down, down. That's it. If you do not understand this point, just imagine you are sitting in a scooter with your friend. Don't look at the ground, just look at your friend. Is he moving for you? Scooter is moving with respect to the ground. You are able to go to a shop, so it is moving. But for you, is your friend who is driving the scooter moving? No. Distance between you is not changing. You and him is not changing. So that person is not moving. If two people have got same velocities in the same direction, one is at rest with respect to the other. So 5 people sitting inside the car, nobody is moving. If car is moving, nobody is moving with respect to each other. Everybody looks stationary. All 5 look stationary with respect to each other. So if you look at x direction, it is 14.7 for the ball, it is 14.7 for the truck. So is ball moving horizontally for the truck? No. Ball is not moving horizontally for the truck. Ball is only moving vertically for the truck. So the person on the truck sees the ball going absolutely straight. Just like you are standing on the ground and you are throwing a ball up, exactly the same way that person will see the ball. No parabolic motion for that person. But the same motion observed by somebody standing on the ground, that person will see that parabolic motion. Anyway, we'll talk about B. First we are talking about A, as seen from the truck. So what will that person on the truck say? The time taken by the truck to travel 58.8 meters, in the same time the ball will go up and will fall back. How much time does the truck take? Truck is going with constant speed. So time taken is distance divided by 14.7. Okay. Now, how do you find speed? For vertical motion, what is y for the total motion, up and down? Initial and final I'm considering, that's it. Initial and final only. 0. Uy is what we want. And t is this. Ay is minus g. So uy will be half g t, half gt. Put this t, put g, and calculate this and see if you are getting around 19.6. As seen by the road, as seen from the road. Find the speed and angle of projection. As seen from the road, ux will be always 14.7. With respect to that truck, ux was 0. Now ux is not 0, 14.7. So as far as u is concerned, for part B, u will be ux square plus uy square under root. Just calculate that. And see if you are getting 24.5. $24.5. Angle of projection. As seen from the ground, Uy is also there, Ux is also there. $19.6, $14.7. In this triangle, tan theta is Uy by Ux. 19.6 by 14.7. This is 4 by 3. If tan theta is 4 by 3, how much is theta? If tan theta is 4 by 3, how much is theta? What's the problem? We discussed two angles, right? 37 and 53. So which one is it? 37 or 53? So that's it. $53 from the horizontal.
Is it correct to write tan inverse of 4 by 3?
It is of course right. Ignore the air resistance as we often do. Okay, ignore air resistance. This is your assignment question. Please stop now.